Hey, good morning. Mr. H here. We are getting down to the nitty gritty here with our rational expressions. Okay, we've looked at finding an LCD. Okay, we've figured that out. We've done some multiplying and dividing, done some factoring in there, done some reducing. Now we get into mega mode. Okay, now we got to lock it in here. We are going to be adding and subtracting rational expressions, which I will admit is the trickiest part of this, but we can get there. We just got to take our time. So back again, we've done recall from grade school before with long division. This is not long division. No part of long division in here. We got to have common denominators to add or subtract fractions. We've talked about this before. So I have another help sheet that you may have noticed in when we're getting rolling here. I'm going to use it on a note card because, well, a note card fits things a little bit better here. So when we're adding or subtracting, okay, first we got to see if we have a common denominator. If we do, sweet, it makes our life easier, okay? So in this case, and as always, we see pluses or minuses. We're doing this to remember they're all together. Oh, dear. So do I have a common denominator? Check. Both my fractions have x plus 3, okay? Our next step, if we have a common denominator, I don't have to worry about the rest of the steps right now. So we're going to get that out of here for the moment. If I have a common denominator, I'm just going to put the stuff together that's up in the numerator. Now, 4x and 12 are not like terms, so I can't really do a whole lot as far as that goes. Yes, everything is moving. Oh, dear. Okay. But here's the deal. Let me pull my card back up. Okay, I didn't have to build the numerator because they're already the same. Simplify, combine like terms, I did that. Is there any more simplifying? Now, that is an interesting question on this one because I look at my numerator, and this is going to be where the simplifying would be. Do those two terms, 4x plus 12, is there anything they have in common that I could pull out? In this case, the answer is yes. They both have a 4. I can divide 4 into both of those. So let's see what that does. If I take out a 4, now notice, I didn't just eliminate it. It's still there. It's just outside the parentheses. We're factoring. So 4 times what gets me to 4x? Well, I need the x. Okay, 4 times what gets me to 12? 3. Oh, check this out. You're like, can I hardly, now am I allowed on this? Because you started yelling at us the other day when we would try to eliminate too many things too fast. Are your parentheses at this point identical? If the answer is yes, then yes, you can wipe those out and get to the answer. But you never cancel until the last step. We're even going to write that here. Never cancel until last step. Ever. Don't do it. We're going to get into some parts here that I'll point that out where people normally would think about doing that. You're not going to be that person, though, because you're going to have this here. You've worked through, and you're going to be an expert. Well, maybe not an expert, but we'll get some progress done here. Okay. Problem 2, now we're going to have to start doing a little work. So I look here, and again, when I'm trying to figure out my common denominator, okay, reminder from when we were finding our LCDs from before. Pull the new help sheet. Coefficients, again, we're just looking at the denominators, don't have any, okay? Single variables, don't have any. Sets of parentheses, okay? Each set that's different is part. So here's what we're going to do. We're going to stretch this out a little longer than I normally would because I want you to see the parts. So here, I'm going to make myself 2 fractions, just like I have here. And each of those fractions is going to have my common denominator, which is each set of unique parentheses, okay? And these are both different, so I need both of them. Now, here's where the fun starts. If you have colors especially here, this could be helpful. So what I already have, I'm going to write up here. Now here comes the goal, and I'm going to cover up some things so we don't get confused here. So let's cover that up. And let's cover maybe. There we go. Okay, here's what I'm trying to figure out right now. To get from here to here, when we're building a numerator, okay, what do I have to multiply by to get from the old to new denominator? So we're just looking at the denominators. What do you see that's in common? Okay, they both have the x plus 5. What did I not check off? The x plus 2. That's the piece that needs to get put in my numerator. Okay? Because think about that for a minute. If, and we're not doing this, so don't cross it out. If I were to look at this normally, I'd say, ooh, those are the same. I cancel them. And look what happens. I'm right back where I started. Okay? But now that this x plus 2 is also in my denominator, part of my LCD, that whatever pieces I don't check off, whatever pieces of the puzzle are missing, that's what I have to put up here in the top. And that's how we build a numerator. Okay? We're going to do that same thing with our next fraction. So we're going to kind of forget about these for a minute. Okay, same idea. Going from here to here, just looking at denominators, what do they have in common? Well, they both have the x plus 2. What did I not check off? What do they not have in common? The x minus 5. That piece gets placed up in the numerator. Because again, if I were to cancel those, I'd have the exact same thing in both. So we're changing what they look like, but we're not changing the value at all because of that capability. Now, here's the part you have to watch out for. Okay? You notice I said never cancel until the last step. Do not cancel those because now you're right back where you started and we don't have a common denominator anymore. Now we have a common denominator. So what do? Okay, once we have the numerator built, simplify the numerators. So we're going to do all of our distributing up here. So we've got 2x squared plus 4x. Okay, this minus that's here goes with our 4. So here's what I'm going to do. And again, I do weird things, I know sometimes, but I think this is a good idea. I'm going to put the minus here because then it just reminds me that negative is going to distribute with when I do this. So minus 4x, negative 4 times negative 5 is positive 20. And I'm going to get this down to one fraction. Okay? So when I'm simplifying the numerator, if there's distributing to do, we do it. If there's like terms that I can combine, I'm also going to do that. As you get better at this, you'll be able to skip steps. But especially when we're doing examples like this, you need to make sure that you take every step as you go here. Even though you're like, I'm writing too much. Well, then give your hand a rest, give it a massage, give it a wiggle, okay? Positive and negative 4x cancel. 2x squared plus 20. So I'm not tempted to do silly things. So you're like, okay, I've simplified it. Now what? Is there any more simplifying to do? Can I take anything out of here? Did 2x squared and 20 have anything in common? The answer, again, in this case is yes. They both have a 2. 2x squared, 2 times 10 is 20. And now comes the moment of truth. Is there anything there that cancels? Okay, this 2 is the only thing that's outside the parentheses. There's nothing else to cancel it with, so I can't do that. Are any of my parentheses identical to each other? Nope. That's as far as I can go. Now, some of you that like to think outside the box are wondering right now, okay, Hardy, I got a question. Since nothing cancels, couldn't I technically leave the answer as this and be correct? Here's what I'm going to tell you as far as that goes. You always need to simplify as far as you can. And what I mean by that is, in a case like this, this would be the equivalent of you saying, can I leave a regular fraction as 3/6 instead of 1/2? Well, no, we simplify. So this is where we're trying to get to, okay? Now, technically, again, is it wrong? If this was a delta math question, you put this and they marked it wrong and you sent me a screenshot, would I give you some credit for this? Yes. Hopefully that takes care of things for you. Okay, let's keep trucking along here. Ooh, new issue to take care of. Okay. New thing to add here on our add or subtract. Ooh, common denominator. We're going to put a little note in under here. You're like, you left that there on purpose, didn't you? Okay, you may have to factor your denominators before you try to find a common one. Okay, you're like, well, couldn't I just write it out like this? Yes, but you're gonna have a lot more work at the end because a lot of times there's gonna be pieces that we can simplify with. So let's do this. This is factorable. Two terms, what are two terms? What do we normally look for again? I got all the help sheets right. This is why you keep these things handy. Two terms, difference of squares, square, square. Oh, it is. It is. Man, I don't give you all those help sheets for no reason. X and 3. A plus B, A minus B. And what I do is, once I factor, I cross all the other stuff out. I don't even want to think about it. Because now, when I go to my first step, which is finding a common denominator, again, when I'm finding the common denominator, don't worry about that numerator stuff. We don't care. Don't care. Okay? Any coefficients? Nope, everything's in parentheses. Okay? Any single exponents? No, everything's in parentheses. So write down each unique set of parentheses you see. So x plus 3, okay. And then I see x minus 3, okay. But then hold it. X minus 3 is not unique. I already have one. You do not need it again. So just something to be aware of with this. You don't need that again. So let's put back what we got already. 6x plus 1 and 4. No canceling and nothing. Don't do it. Now go into what we were doing before, okay? One fraction at a time. Don't care about that stuff right now. Now check this out. X plus 3, x minus 3. Everything checks out. So Hardy, what do? Everything checked. You can leave it, or you can say if I want to put something in, I can always put in a 1, because multiplying something by 1 doesn't change anything. But if you have all the parts, there's really not that much you're going to have to do. Then we do it again here. And I look, okay, x minus 3. Ooh, but I didn't check off the x plus 3. Whatever doesn't get checked off, we write up in the numerator. Because again, if I were to cancel them, but we're not, I'd get the same thing back. So we've taken care of our first part, okay? We did the common denominator. We built the numerator. Simplify the numerators, okay? Well, here, let's see. One big fraction, x plus 3, x minus 3. Distributing 1 really doesn't do anything, so 6x plus 1. But here, the 4 distributes, and it was plus. I don't have to do any sign changes or anything. So plus 4x, 4 times 3 is 12. And combine like terms, just like we normally would with anything algebraic. 6x and 4x is 10x. 1 plus 12 is 13. And the question becomes, can I simplify it any further? 10 and 13 have anything in common? Nope. Are any of the sets of the parentheses the same? Nope. Good. And we're set. Okay? A lot of times this is going to happen. It's not like every single one of these problems is going to break down, break down, break down. Now, some of them may. But in situations like this, nope, that's as far as I can go. All right, 1 to go. And you're wondering, is this going to be the crazy problem where you got to do 8 million things? So let's get in here and find out. Factoring city. Whoop, whoop. Okay. All right, let's do what we normally do. multiply, add. Look for clues. Multiply number is negative. One of each sign. Multiplies to 4 and are 3 apart. Geez, this isn't hard. 2 and 2 or 4 and 1? Oh, 4 and 1 are 3 apart. Bigger sign is negative. 4 and 1. That's my new denominator on the first one. Second one. Same process. Multiply and add. Okay, multiply is negative. One of each sign. There's only one way to get to 2, 2 and 1. That's the sign of the bigger number. 2 and 1. Okay. Denominators are now ready for us to get in here. All right, what do we got working here? We got an x plus 1. We got an x minus 4. We already have an x plus 1. Don't do it again. But we don't have an x minus 2 yet. So this is a little bit chunky of a denominator, but that's okay. Put the 5, put the 3. They're still part. And do what we've been doing. Problem to problem to problem here. Okay, I don't care about all that stuff right now. So let's look. Got the x plus 1. Got the x minus 4. You don't have a check mark. We put you up here. That's all this is going to be each time. And it could be a set of parentheses. It may just be a variable term. Okay? It can depend a little bit. It can change up some. This is why it's good to do practice on stuff so you can ask questions if you run into issues. So I want to help. Okay, 3. I got the x plus 1. I got the x minus 2. I don't have this. X minus 4. And as we've run into in other situations, if it's a minus in the middle and you see there's distributing to be done, again, personal preference. I like to put the negative right on there so I don't forget it. And again, if we're at a point where you're like, dude, my hand's cramping, I'm famished, I can't, okay, give it the wiggle, give it the wiggle. If you think you're dehydrated and that's why your hand hurts, quick water break, okay? Let's clean this up. 5x minus 10. Negative 3x, negative times negative is plus 12. Put the stuff that's alike together. Let's see here. 5 minus 3 would be 2x. Negative 10 plus 12 would be plus 2. You're like, Hardy, your head's getting in the way. Okay, just a minute. Let me move me. There we go. Now, am I done? Now, the question always is with this, anything in common? Yes, Hardy, there is. There is a 2. Oh, my gosh. My hand is going to fall off. No, it's not. And those of you that have been trigger happy this entire time after doing the multiply and divide section where we got to like cancel all this stuff, you finally get to do that here. Because now we've simplified everything. We're at the last step. Now, do you see stuff that's alike? Yes. Can you cancel it now? Yes, because this is the last step. So Hardy, I want to cancel more. Can I cancel the 2's? No. Parentheses, not in parentheses. That's as far as you're going. Okay? That's how these bad boys work. You're like, oh, Hardy, this is... Look at that. We just did like 4 problems and it took up like 15 sheets of paper. You killed 27 trees. Again, for the good of the cause, for the good of your brain expanding, we're killing off a couple of trees here. At least I don't kill off trees with the summatives. Okay? So again, you have got practice that you can work on, okay? To get better at this, the answers are on the back of the sheet actually this time. Well, they're on the site too if you need them. but get your practice in, okay? That's going to make the summatives a whole lot easier. Well, it's also going to make it easier when we get to 8.6 and we're solving equations with these. Oh, joy. But keep working at it. Keep asking questions. Keep sending me pictures of stuff. When you're in the middle of a problem, you're like, I am not getting that answer. Here's my thing. Because we can work this out. We just got to keep the communication lines open. So keep at it. Give it a shot. Let me know if there's anything else I can do, and we'll see you next time.